Incredible. We're here at a track to showcase how the Corvette Z06 raises the standard for performance cars everywhere. This bona fide racer is guaranteed to boost your adrenaline and raise your pulse. Under the hood, you'll find the legendary LS6 engine. Now, I say legendary because the LS6 designation has been used only once before in Corvette history, on the 1971 Special Edition 454 V8, one of the most powerful production Corvette engines ever offered. The Corvette team has brought the LS6 back to pay homage to this outstanding performer and to stake its claim to its high-performance, street-legal heritage. Just a few minutes behind the wheel will convince you that the new LS6 is a worthy successor.
Well, this engine was specifically designed for the Z06 Corvette, a real high-performance vehicle, and we wanted to make sure that the engine had the character that the vehicle was going to need. Basically, what we did when we designed this engine was focused on trying to bring the air into the engine and out as efficient as possible. So what we did is we actually revised the whole tooling of the intake, and we took the floor and dropped the floor of the plenum down and then modified the bell mouth of the runners into the cylinder head so that we could actually improve the airflow into the engine. We've also improved the combustion chamber of the engine. We increased the compression ratio from a 10.1 to 1 to a 10.5 to 1. The exhaust manifolds have also been redesigned. They're actually a thin wall cast iron manifold done primarily to improve the airflow again out of the engine, out of the exhaust port, as well as add improved durability for this high output package. One of the enablers to obtain the higher speed capability of the engine was to manage the airflow not only in and out of the engine, but also internally to the engine. The way we accomplish that with this is as the piston is actually flowing down, it actually tries to displace air. And we need to put that air someplace. And right now, as the piston flows down, what we've done is actually cast passages, slots, in the actual bulkhead of the block. And as the piston comes down, it displaces the air to adjacent cylinder bay. And therefore, we don't have that resistance, nor the air going back down to the crankcase and aerating the oil. We also expanded the whole bandwidth so that the vehicle is good from off the line all the way through 6,600 RPM. It's a real performance-oriented engine for that performance vehicle. One key feature for a high-performance engine is the camshaft and valve train. In fact, I consider the heart and soul of the engine. It really gives the character of the engine. We wanted to maintain our top-end performance without giving up any of our low-end torque. We did develop a cam profile that increased the lift from 13.3 millimeters to 14 millimeters. To complement the cam's high lift, we hollowed out the inlet and exhaust valves, as well as modified the valve springs, increasing its stiffness. So it really makes a high-performance engine for a high-performance vehicle.
A fitting complement to the LS6 engine is a new state-of-the-art titanium exhaust system. Titanium has an extraordinary strength-to-weight ratio and is extremely temperature-resistant, which is why it's found in jet engines and high-performance military aircraft. And because titanium is approximately 40% lighter than stainless steel, using it in Z06's exhaust saves nearly 18 pounds. Titanium's anti-corrosive properties are also very good. In fact, the mufflers on your Z06 will outlive their stainless steel counterparts. And speaking of mufflers, Z06 includes a completely new muffler design. Large louver tubes inside the mufflers improve breathing and reduce back pressure to help the engine achieve maximum performance. The exhaust tips are different too, with 4 3.5-inch chrome flash tips that visually set the Z06 apart. But besides looking different, the exhaust system also sounds different. The mufflers have been specially tuned to deliver a low, sporty growl that's distinctive to the Z06. In keeping with its sporty and distinctive nature, the 6-speed manual transmission on your Z06 is specially geared to provide more aggressive launch and acceleration through the gears. It also includes a temperature sensor to safeguard against extreme thermal stresses. The transmission is located away from the engine, back here, just ahead of the rear axle. A prop shaft runs through a structural center tunnel, connecting the transmission to the engine. To handle the high torque of the LS6 engine, the rear axle has been strengthened and the clutch redesigned. The clutch has higher clamping capabilities to smoothly transfer the higher power outputs. At the same time, it requires less pedal effort to engage, a benefit you'll appreciate on the track and in stop-and-go traffic. An interesting fact about Corvette's powertrain is that beyond just generating a lot of power, It enables the structure's tunnel configuration to literally serve as the backbone of the car, which contributes to the vehicle's excellent rigidity. And by putting the transmission in the rear, Corvette engineers were able to achieve a 51-49 front-to-rear weight distribution, a big factor in Corvette's world-class handling capabilities. Finally, the rear-mounted transmission design allows for plenty of space for driver and passenger footroom, which you'll appreciate every time you take a long trip. Corvette's great structure translates into a variety of benefits to you as a driver. It provides a comfortable ride, responsive, controlled handling, and precise steering control, whether you're racing on the track or just running around town. The structure starts with a full-length perimeter frame that acts as the foundation for the rest of the car. You can see the structural transmission tunnel running through the center. The side rails provide rigidity, but are still lightweight despite their size. That's because they're hydroformed, molded from the inside by ultra-high-pressure water injection. Innovative manufacturing techniques and materials are found throughout the car. Take the floor pan. It's made of balsa wood, covered by composite material. Balsa wood is very light, and when you sandwich it between high-strength composite material like this, you get a strong, lightweight, structural component that also helps absorb noise and vibration. The same commitment to advanced engineering technology that went into Corvette's body structure is also very evident in its exterior design and styling. The classic Corvette design cues are prominent, and the .31 coefficient of drag makes it one of the sleekest sports cars available. In contrast to the standard Corvette, your Z06 has functional air intakes in the front fascia with stainless steel grill inserts. The air intakes help improve airflow to the engine air inlet. In the rear, brake cooling scoops located just ahead of the rear wheels also help distinguish the Z06. The scoops direct cool air to the rear brakes to help reduce temperatures under heavy usage, a very significant benefit, especially on the racetrack. A well-designed, competent chassis is essential to ensuring that your Z06 stops, turns, and holds the road as well as it accelerates. Starting with the tires, great attention was focused on all aspects of the suspension to make sure that the Z06 was up to the challenges of the road as well as the track. The Z06 features specially designed and engineered Goodyear Eagle F1 supercar tires. To minimize tire mass, Goodyear went with a non-extended mobility design, which resulted in a weight savings of over 23 pounds. Plus, the unique tread configuration and the extra width of the tires combined to make the Z06 handle, brake, and ride like an enthusiast's dream.
The Z06 is the first Corvette that we've ever produced that is capable of producing over 1G lateral acceleration. There's a lot of things we did in the chassis that contribute to that. The most important thing, of course, is the tires. We got 4 tires on the ground with about this much contact that's all between the tire, or all between the car and the road. This is the tire that we use on the base Corvette and our current Z51 suspension. This tire is a run-flat tire. It's a directional tire. The grooves are cut from the center, swinging out. It's meant to move in a certain direction. As it goes through, it takes the water from a wet road and displaces it sideways, gets it out from underneath the foot. For the Z06, we cared about the extreme enthusiast. That guy wants to go, and he wants to go fast, and he wants to corner hard. So we needed a new tire that had even more capability than what we had in our present Corvette. We designed a tire that will have an even higher level of performance. It is an asymmetric tire instead of a directional tire. By that we mean the tread pattern is different on the outside of the tire versus on the inside of the tire. The outside of the tire is got very large elements with very small grooves. They're very stable elements, and they can generate a tremendous amount of cornering power. The inside elements are there to give us still some range performance, not as much range performance as we had with the current F1 GS tire, but still some range performance. Very large grooves, they get the water out.
The wheels on the Z06 are special too. In fact, they're the most mass-efficient aluminum wheels ever produced for Corvette. Plus, they look great. The light gray complexion contrasts perfectly with the torch red brake calipers, a signature look for your Z06. Complementing these high-performance wheels and tires, the Z06 exclusive FE4 four-wheel independent suspension features a short and long arm, or SLA, design at all four corners. SLA is also known as a double wishbone due to the V-like shape of the upper and lower control arms. In contrast to the standard Corvette suspension, the FE4 has received several enhancements to better handle the aggressive high-speed maneuvers you'll encounter on the track.
To get the most from the tires, we developed a specific suspension for the Z06. The first thing we did was increase the static negative camber alignment, both in the front and in the rear. We added camber by -0.5 degree, both front and rear. The next thing we did was try to keep the body from rolling as much. We increased the front roll bar stiffness, and we also went to the rear and increased the rear spring stiffness. Both of those things keep the body flatter. That keeps the tire flatter. That generates more cornering power. The rear spring has another benefit by keeping the back of the car from squatting down as much when you're accelerating. That helps put more power to the ground by keeping the back of the car off of the jounce bumper. In addition, we shortened the jounce bumper for the same reason. Final thing we did for the Z06 suspension is valved a specific shock valving. It has tighter, lower speed body control. That gives us more control during quick transitions through slaloms and chicanes.
Helping you maintain the ultimate control as a driver is Corvette's standard active handling system.
In simple terms, active handling helps correct the difference between the driver's intended direction for the car during a turn and the actual direction. Its benefits are most noticeable during slippery road conditions or performance handling situations. It's truly the next step in the evolution of Corvette's ABS and traction control. Now, to measure the driver's intended cornering direction, the system incorporates a steering wheel angle sensor, individual wheel sensors, an accelerator pedal sensor, a brake switch, and a master cylinder pressure sensor. It uses this information to determine the driver's desired yaw rate and speed. Yaw rate is simply the speed at which the car turns or rotates as it corners. The system also measures the car's actual yaw rate and lateral acceleration using two new and specific transducers, an accelerometer and a yaw rate sensor. The active handling system activates when there's a significant enough difference between how the driver intends for the car to corner and how it is actually cornering. It automatically applies any of the vehicle's four brakes to assist in correcting the situation. Now here's an animation developed by our engineering team to help show the performance of active handling. It simulates an aggressive lane change maneuver on a wet surface. The white car is equipped with active handling, and the blue car is not. As the car enters the maneuver, the driver applies more steering input than the car can react to. The car starts to push or understeer. The active handling system senses this and applies the inside rear brake, helping to pull the car into the corner. Once the car is in the left lane, the driver tries to straighten it out, but the yaw inertia of the car causes it to turn more than the driver wanted. Active handling reacts to this oversteer condition by applying the outside front wheel brake. The resulting torque helps keep the rear end of the car from getting too loose. As the driver returns to the right lane, a similar sequence of events unfolds, worsened by the whipping action of the maneuver. The active handling system assists the driver in maintaining control by applying the brakes appropriately. This affords the driver a greater level of control, as well as gradually slowing the car to a more manageable speed. The overall effectiveness of the Corvette active handling system, or any similar system, is directly related to the available tire traction and the aggressiveness of the given maneuver. Active handling is designed to better utilize available traction to assist the driver, but it cannot overcome the laws of physics. The active handling system reacts only in extreme situations, so special care should be taken when the system does activate, because that's a clear signal that the vehicle or tire limits are being exceeded. Now, in most situations, the system will help the driver maintain control without being intrusive. Corvette's active handling is also the first system of this type to offer a dual mode operation. You can select the competitive driving mode for autocross or gymkhana competition. The competitive mode maintains the individual wheel braking of active handling, but it disables traction control. Our testing indicates that the lap times of typical Corvette drivers will likely improve with this new system, especially if the driver is just learning the course.
Just like the suspension system, Corvette's MagnaSteer variable effort steering system is designed to perform well through a variety of driving situations. It provides easier turning effort at low speeds, like in parking lots, and firmer steering feel at highway speeds. Corvette's interior serves a dual role, emphasizing driver control while providing exceptional comfort. The bucket seats have lateral support, back angle adjustments, and a 6-way power driver's seat adjuster. Now, there are times when you may notice a little play in the seat back. That's perfectly normal. The seat is designed that way to prevent damage that may be caused by moving the seat rearward when it's fully reclined. Now, the best way to recline your seat is to first move it to your preferred distance from the foot pedals, then lean forward, taking most of your weight off the seat back, lift the lever to recline the seat, release the lever, and then sit back. Once you're in the proper driving position, Corvette's head-up display feature helps you keep track of critical display functions without taking your eyes off the road.
The head-up display system takes the display information, puts it through an optical system, and projects it up onto your windshield. It's taken from aircraft technology that's been around for a number of years. The Corvette head-up display was designed to be able to accommodate mostly the performance driver. It allows the driver now to be able to see their tach, gauges, and other information that other head-up displays don't provide. There are 4 key components to your head-up display. The head-up display itself, the windshield, which contains a scientifically adjusted anti-lacerative layer, which provides a nice crisp image to the driver. The instrument cluster, which provides the data to the HUD to keep it accurate. And the switches, which are located here on the left side of the instrument cluster. The top switch, or the page switch, allows the driver to be able to add and subtract format to their preference. The dimmer switch allows the driver to be able to adjust their image to a brightness level which they're comfortable. And the display switch allows the driver to be able to adjust the image and center it within their seated height. Some of the key things to remember when using your head-up display are to be able to keep your brightness down to the lowest level possible where you're still comfortable driving and you can still see the image. One of the other things is to try to keep your content down. For instance, if you're driving in the city, you may not want to have all your information up. You may want to limit it to just your speed. If you are driving under a high-pressure situation during a race, for instance, you may want to have your tach and your gauge information showing. There's really no special care required for your head-up display. If you do need to clean the lens, just use a piece of cloth and some household glass cleaner and go ahead and wipe the lens. Be very careful, though, not to press too hard.
In addition to finding ways to improve the performance of your Z06, Corvette engineers looked for ways to reduce its mass.
We based the Z06 on the hard-top body style because it is the lightest and stiffest of the Corvette models. For the Z06, we looked to expand that advantage by taking additional mass out of the car. The reason for that is the power-to-weight ratio is a large determiner of racetrack performance, also on the drag strip. But in addition to just that, taking weight out of the car helps the other elements of track performance, braking, absolute cornering, and also transients, where you're changing from one direction to another. Having a lighter car enables that performance. We looked all around the car to make mass reductions wherever we could. The non-EMT tires take out a significant amount of mass. The first mass production titanium exhaust system takes out another large amount of mass. And then we looked all around the cars for small mass changes like thinning up the glass a little bit in the back. The windshield is a little thinner than the other Corvette models, and even the battery is a new technology to help take weight off the front end of the car. The final result, when we were all done, is that the Z06 is 38 pounds lighter, and that's in spite of numerous content additions, the stiffened chassis, the upgraded motor, and the body panels. All taken together, this car weighs about 117 pounds lighter than the typical convertible or coupe. With the power you've heard about and the reduced mass, this Z06 will be a force to be reckoned with amongst high-performance sports cars.
I hope you've enjoyed this brief overview of your new Z06 Corvette. In the upcoming segments of this tape, you'll learn a lot more about key features and operations. You'll learn how to set your Z06 up for competitive racing and how to maximize its performance on the track. Whether you drive in competitive events or just around town, you'll see that Corvette is designed to give you the best possible driving experience. Enjoy the rest of the program, and thanks for watching.
The Corvette doesn't require any special break-in period above and beyond what you would do for any new car. Basically what that means is for the first 500 miles you want to take it easy. That means limiting wide open throttle, accelerations. When launching the car from rest you want to take it easy in either a manual or an automatic. And you want to try to keep the car seeing a variety of speeds during the course of that 500 miles. Try not to have the engine running at 1 RPM or 1 steady state speed for an extended period during that time. The reason for that is that the mechanical parts are seating together. They're meshing together for the first time, and they're wearing together to create a smooth running machine. If you put a lot of energy into the car, either through heavy braking or high intensity accelerations, you could create some wear patterns that would result in either noise or the car may not be as smooth as it could have been. For brakes, this especially important part is the first 200 miles. You want to make sure that you leave enough room in traffic that you never have to get into a panic stop situation, that for those first 200 miles you can brake moderately at all times. It is true that the Corvette air dam is quite low to the ground. The reason it's there is aerodynamics. All the Corvette models need to have extremely good aerodynamics. Now, sports cars are not naturally aerodynamic. They tend to be wide and low, they tend to have big tires, they have large engines that need a lot of air for cooling. So aerodynamic achievement is very difficult on a sports car, yet it is absolutely essential for the Corvette so that we can have the astonishing acceleration performance and powertrain performance coupled with surprisingly good fuel economy and no gas guzzler tax. One of the ways we achieved that aerodynamic performance was to bring this air dam or valance down close to the ground. It sits about 4 or 5 inches above the ground, and so it can make contact on large road obstacles such as large speed bumps or steep driveway ramps. It's designed to accommodate those kinds of obstacles. It consists of 3 pieces, 2 outboard sections that are made of a tough, flexible plastic, and a center section that also flexes quite a long way and can spring back into position. In spite of the robust design of the air dam, the best advice I can give is to follow the instructions in the owner's manual. Namely, use caution when approaching obstacles in the road. Large speed bumps, curbs, steep driveway ramps should all be approached with caution. The best idea is to get the car slowed down before you get to the obstacle. The reason is you don't want to be braking as you make contact with the obstacle because the braking actually pushes the nose of the car down and makes the air dam even lower than it already is. So following those directions, you may hear some noise in the car when the air dam makes contact with those obstacles, but it will flex out of the way and will continue to perform its important aerodynamic and engine cooling functions. Some customers have asked about a mechanical buzz or rattle noise coming from underneath the car. It sounds like this. This noise is not an indication of a problem. It's a characteristic noise inherent in the driveline configuration of the Corvette. With a high output V8 engine in the front and a high capacity rear mounted transmission, that noise is simply inherent characteristic of that driveline design. The Corvette's driveline has been designed to be as powerful, lightweight, and simple as possible, and therefore as reliable as we can possibly make it. Another question we get from manual transmission customers concerns the skip shift feature. This system guides the shift lever from first to fourth under light-duty conditions and has been on Corvettes since the 6-speed manual transmission was introduced in 1989. Its purpose is to enable the best possible fuel economy in city driving while offering the maximum performance when demanded. The fuel efficiency of many high-performance sports cars
causes their buyers to pay substantial gas guzzler taxes. We have tried to make the skip shift feature as unintrusive as possible to give you the best fuel efficiency around town. Your owner's manual gives more details on the exact conditions under which the skip shift will operate. Skip shift is just another way we have designed your Corvette to achieve astonishing performance and fuel economy and avoid this tax penalty. I'd like to make sure there's no confusion on the proper operation of the Corvette's optional electronic HVAC control. You will see the AC light come on whenever the air conditioning compressor is engaged. This can cause confusion when you select the defrost mode, especially when it's cold out. Most of the time, the AC light will come on even when you have the temperature set to warm up the car. This is because the compressor engages to take the moisture out of the air. This makes the defroster function much more effectively and will not slow down how quickly the car warms up.
When I get into a Corvette to take a drive, what I like to do first is get myself in the right position for operation of the pedals and the steering wheel. It's most important that when you're pushing on the brake pedal that you have your knee bent. In order to get in the position so that you have a bent knee when you're braking, I like to reach to the floor pan, and if I can get my toes to the floor pan comfortably, then I'm close enough to the brake pedal. In this case, I'm too far away, so I move myself up to where my toes are comfortably on the floor pan. That way, when I'm pushing on the brake pedal, I'll have a bent leg and I can get good leverage on the brake pedal in case I need it for an emergency stop. The second most important thing is to have good control of the steering wheel. I like to be in a position where I can comfortably lay my hand over the steering wheel so that when I'm steering, I've got good leverage on the steering wheel. In this case, I'm too far away, so I'll bring the back up just a bit so that I can get nice, comfortable reach on the steering wheel. Most of maintaining the proper seating position is designed into the seat and the controls, but the seat belt is also part of the overall seating position in the Corvette. The seat belt buckle moves with the seat, so that it's always in the right position to buckle up the seat belt and give you the most control. Then if you're driving the Corvette in a more sporting manner to get additional control, you can use what we call the cinch feature. Pull the seat belt out all the way and allow it to ratchet back in, and that locks it in position to really hold you well in the seat. The Z06 Corvette is a very high-performance sports car, so if you're going to take it out on the track, there's a few things you need to keep in mind. Let's go for a ride and we'll talk about it. Probably the most important thing to remember when driving a really high-performance car like the Z06, a car with this much power, powerful brakes, very sticky tires, is being absolutely smooth. Smooth when getting on the brakes, smooth when applying the power, because there is so much power that you can easily spin the rear tires when you go to wide open throttle. So everything needs to be done smoothly. Even down at the end of the straightaway coming into the turn, don't really stand on the brakes. Apply the brakes smoothly and take them up to full power gradually. Let off them smoothly. When you do it that way, the transition into the turn will be a lot smoother. Do nice, smooth heel and toe downshifts. You'll find that most of the time when going through transitions like this, that you won't need to use all of the track because the cars will be going so fast that you don't have time to get back over to the other part of the track, like this section right here. You could actually hear the rear tire spin just a little bit going over the hill. So whenever you're on an over-the-hill turn like this, be very careful about going to wide open throttle, because as the rear end gets light, the tires will start spinning. Brake very smoothly, turn in, apply the power very smoothly. Was that fun or what?